Hi class, we're now on our third day of 2.2 and 2.4. We've been talking about point slope form, slope intercept form, standard form with graphs, and so on and so forth. We're going to continue doing that today, but specializing now with parallel and perpendicular lines. So let's now review on what a parallel line is and a perpendicular line. So what parallel lines are is they are lines that have the exact same slope. So lines that have the same slope. So parallel lines, just a refresher from geometry, are two lines that never ever touch each other. They go on forever and ever and ever, and they never get any closer to each other. They never get any further away from each other. They just stay the exact same distance forever and forever for all eternity for the distance that they go. So it would make sense that if one has a slope of up 1, 2, 3 over 1, if it goes up 3 over 1, up 3 over 1, up 3 over 1, so on and so forth, that the other one would also have a slope of up 3 over 1, up 3 over 1, so on and so forth. They're going to have the exact same slope because they're going to stay the exact same distance forever and ever and ever. Perpendicular lines, however, they intersect each other and they have a special intersection. They have negative reciprocal slopes, which I'm sure you guys remember what that is, but if you forgot, all it means is that whatever the fraction is for the slope, you put a negative sign on it, so you change the sign, and then you do the reciprocal, which means the denominator goes to the numerator and the numerator goes to the denominator. So if the slope was 5/3, the perpendicular slope is a negative 3/5. You just put a negative sign on it and you flip-flop the fraction. Now, like I said, perpendicular lines, they intersect and they have a special intersection point. I'm sure you remember from geometry. That intersection point is a right angle, a 90-degree angle. So that special intersection with that 90-degree angle makes perpendicular lines very valuable to us because there's so many shapes and so many figures in our everyday life that have 90-degree angles, which are perpendicular lines. So we have to be able to utilize these forms of lines very efficiently. So let's talk about this first one. We're going to write an equation for a line that is parallel and perpendicular to the line given and passes through the given ordered pair. So here's our line. So let's just break this down here for a second. We have this graph. You don't have to write this down, class. Just think with me for a second. It crosses my y-intercept, my y-axis at a positive 1, and then my slope is down 1 over 2. So here is the line that this is, right? And so what we want to do is we want to find a line that is parallel to that one that goes through the point 1, 5. So let's just say 1, 5 is right about there. So what I want is I want a line that is parallel to this one. So if I were to put it on a graph, it should look like this. I also want one that is perpendicular to this red line. So that means it crosses it, and it crosses at a 90-degree angle, and it's going to go through the point 1, 5. So at 1, 5, I want it perpendicular, so it might be something, this is a rough sketch here, it might look something like that. Right? It's perpendicular to that line, and it still goes to the point 1, 5. So if we were to put these equations on a graph, that's what we would see. Now on your directions, it wants it in point slope form, slope intercept form, and standard form, so we're going to get very, very, very good at using these three forms. So let's try it right now. We want to go through the point 1, 5. So if we want point slope form, we have our point. We now need our slope. And hopefully you guys see where our slope is. Y equals mx plus b form is what this is in. So our slope is that m, negative 1/2. So if I have my slope, I have my point, I could put it into point slope form, which is y minus y1 equals m times the quantity x minus x1. So we have y minus 5. That equals a negative 1/2 times the quantity x minus the x coordinate, which is x minus 1. Here's our first answer for, I should have put up here, this is for parallel lines. This is for our parallel. Y minus 5 equals a negative 1/2 times the quantity x minus 1. So now let's get our second answer, and that's in slope intercept form. Let's distribute this negative 1/2. So y minus 5 equals a negative half x plus 1/2, because a negative 1 times a negative 1/2 is a positive 1/2. Let's add our 5. So y equals a negative 1/2 x. 1/2 plus 5 is 5.5, which is the same thing as 11/2. There is answer number 2 in slope-intercept form. So answer number 3 has to be in standard form. So we need our x's and our y's on the same side. So we're going to add 1/2 x. So 1/2 x plus a y equals 11/2. Standard form says we can't have any fractions, we can't have any decimals, the greatest common factor has to be 1, and there can't be any negative coefficients. So if I see fractions, I got to get rid of them. Let's multiply by the least common multiple of 2. So now we have 1x, or x as I multiply, plus 2 times y, which is 2y. That equals 11/2 times 2 is 11. Here is answer number 3. Now, you're half done because you found point, slope, slope-intercept in standard form for a parallel line. So what you found is with our graph that we had right here, you found 3 forms of writing this line. So now what we're going to do is we're going to find 3 points, or 3 lines, for graphing the perpendicular line, the one that forms a 90-degree angle. So that's what we're going to work on right now. So on our perpendicular side, we still have our point as being 1, 5. So now what we need, perpendicular, now what we need is we need our negative reciprocal slope. So if our slope is a negative 1/2, that means our perpendicular slope, this figure right here means perpendicular, so our perpendicular slope is going to be a positive 2/1, or just a positive 2. And now we're going to do all this work again with our slope as being a positive 2. Alright, let's go to work. We have our first answer, y minus the y coordinate. So y minus 5. That equals m, our perpendicular m, which is 2. 2 times the quantity x minus the x coordinate, which is x minus 1. So there is answer number 1. Answer number 2, let's get this sucker into y equals mx plus b form. So y minus 5, that equals 2x minus 2. Now we're going to add 5 to both sides, and voila, we have our slope-intercept form of y equals 2x plus 3. We're cruising. Y equals 2x plus 3. So our last answer is going to be getting it into standard form. So that's saying that we need to get x and y on the same side, so let's subtract 2x from both sides. A negative 2x plus a y equals a positive 3. I have these big red flashes going on in my brain right now because I cannot have a negative coefficient in front of x. So that negative 2 has to be positive, so I'm going to multiply everything by a negative 1, or basically I'm just going to change the signs on all of them. And so my standard form answer is a positive 2x minus y equals a negative 3. 2x minus y equals a negative 3. Whew! That is what I need to see on a test when I ask you to give me the parallel and perpendicular form of a line that goes through a certain point. I need to see 6 answers. Slope-intercept, standard, and point-slope form for parallel and for perpendicular. So I need to see those 6 answers. You guys take a few minutes and why don't you try it all on your own. Pause the video, please, and try number 2 on your own. So for parallel, here's what you should have gotten. You should have gotten y minus the y coordinate equals m, which our slope is 2, times the quantity x minus the x coordinate. So x minus the minus 1 is x plus 1. Here is answer number 1. Answer number 2. Y minus 2 equals 2x plus 2, so y equals 2x plus 4. There should have been answer number 2. Answer number 3, changing it into standard form, is a negative 2x plus a y equals 4. So we would get then the answer of a, multiplying everything by a negative 1 to get rid of our negative coefficient, our positive 2x minus a y equals a negative 4. Positive 2x minus y equals a negative 4. Hopefully you got these 3 answers for a parallel line. For a perpendicular line, let's now use our negative reciprocal. So if m equals 2, our perpendicular m, our perpendicular slope is a negative 1/2. This is the same thing as 2 over 1, so negative reciprocal would be a negative 1 over 2. So now let's go through the same work again. Y minus the y coordinate equals our m, which is negative 1/2, times the quantity x minus the x coordinate. Answer number 1. Answer number 2. We're going to get rid of our parentheses, so y minus 2 equals a negative 1/2 x minus a 1/2. Let's add 2 over here to get y all by itself. So y equals a negative 1/2 x plus 2 minus a 1/2 is 3/2. So this, my friends, is answer number 2 for perpendicular. It's our slope-intercept form. And now finally getting it into standard form, let's add the 1/2. So 1/2 x plus a y equals a positive 3/2. I cannot have fractions in my answer, so what I'm going to do is I'm going to multiply everything by the denominator of 2. And then I would get 1x plus 2y equals a positive 3. X plus 2y equals 3. And there are the 6 answers hopefully you arrived at when you did this on your own. If you got something else, hopefully this work makes sense to you. If it does not, please, please, please ask a friend or ask myself on how I got these 6 answers. Let's try this one. I want it parallel and perpendicular. So if I know it goes to the point 2, 3, what I need to know is I need to know the slope, because the first step is putting it into point slope form. And stink bomb, I don't know a slope. I just know x plus 3y equals 6 is our formula. So if this is in standard form, I wonder if I could change it into y equals mx plus b form. And once I get into y equals mx plus b form, I got my slope. Let's do that. So let's get y all by itself. X, I got to get you over here. So I'm going to subtract you. So 3y equals a negative x plus 6. And now I divide both sides by 3. And so I get y equals a negative 1/3 x plus 2. So this and this are the exact same line. This one is in standard form. This one is in slope-intercept form. I put it into slope-intercept form because now what do I know? I know that my slope is a negative 1/3. So my m is a negative 1/3. That was the reason for doing all this, because now I know my slope. Alright, if I want to make a parallel line, I know that my line has to have the same slope as a negative 1/3. So now let's go through all of our work that we did in the past 2 problems with my slope being a negative 1/3. Hoorah! Let's do it. We have y minus the y coordinate equals m, which is a negative 1/3, times the quantity x minus the x coordinate. Answer number 1. Answer number 2. Y minus 3 equals distributing a negative 1/3 x plus 2/3, because a negative times a negative is a positive. Adding the 3, y equals a negative 1/3 x. When I add 3, 3 plus 2/3 is 3 2/3. Which makes 11/3 as an improper fraction, plus 11/3. Here is answer number 2. Answer number 3 is standard form. Let's get our x's to the left, so we're going to add 1/3 x. So a positive 1/3 x plus a y equals 11/3. I can't be done here because I have fractions. Let's get rid of them. Multiply everything by the least common multiple of 3, and we get 1x plus 3y equals 11. There is answer number 3. Let's continue doing this exact same thing for our perpendicular lines. So now, if my slope is a negative 1/3, my perpendicular slope is going to be a positive 3 over 1, or a positive 3. So answer number 4. Y minus the y coordinate, which is y minus 3, equals our perpendicular slope, 3, times the quantity x minus the x coordinate, x minus 2. Here is answer number 4. Answer number 5. Let's keep on going. We have y minus 3 equals, getting rid of the parentheses by distributing, we have 3x minus 6. Adding 3 to both sides, we got y equals 3x minus 3. There is answer number 5. Y equals 3x minus 3. And finally, answer number 6, we're going to subtract 3x to get our x's and y's on the same side with standard form. A negative 3x plus a y equals a negative 3. And then I have a negative coefficient, so let's multiply everything by a negative 1, and that'll make a positive 3x minus y equals a positive 3, and that is going to be answer number 6. So that's how I do problem number 3. Problem number 4, slightly tricky. Let's go through it all in class together. We have a line of y minus 5 equals 0, and we want a parallel line that goes through a negative 3, 2, and we want a perpendicular line. Let's think about this logically for a second. Let's get this one into y equals mx plus b form, which means get y all by itself. So then you would just add 5, so we would get y equals a positive 5. Well, what do you know about a line that is only y equals? Hopefully you know that it is horizontal. So on a graph paper, you would go 1, 2, 3, 4, 5, and voila, there's my line. So what do I want, class? I want a line that's parallel to it, that goes through a negative 3, 2. So a negative 1, 2, 3, and a positive 2. I want a parallel line that goes right through that point. So if it's parallel to a horizontal line, will it not also be parallel? That just makes sense, right? It's going to be parallel to the green one. So if it goes through this point, it's going to go, if this one stays at 5, the green one stays at 5, then the blue one is going to stay at 2. So this line right here is just the line y equals 2. And that is the point slope form, the slope intercept form, and the standard form. It is just y equals 2. So here's my answer for parallel. So now what I want is I want a line that is perpendicular to this green one that goes through this now red point. If I want it perpendicular, what's a 90-degree angle for a horizontal line? It would be a vertical line. Boo! Boo! Right? A vertical line and a horizontal line make perfectly 90-degree angles. Hopefully all of our structures that you live in and that you go into and so on and so forth have horizontal lines and vertical lines. Hopefully a contractor leveled them in such a way that makes a 90-degree angle. That's what they're supposed to be made. So if it's a vertical line is an x equals line. It's an x equals whatever coordinate it is. So the coordinate here is this negative 3. X equals a negative 3. And that is the answer for all 3 of them for slope intercept, standard, and point slope. So there we have problem number 4. Hopefully that makes sense to you. Last one, you're going to have some accelerated math objectives like this. Are these two lines parallel, perpendicular, or neither? Well, I know that if the slopes are the same, they are going to be parallel lines. If the slopes are negative reciprocals, they are going to be perpendicular. If the slopes are anything else, if they're not the same, anything else. If they're not the same, if they're not negative reciprocals, then if they're anything else, we would write down the answer, neither. So hopefully these ones are basic enough. All we need to do is find the slope. So my best strategy for finding slope is to put it into y equals mx plus b form. So let's get this y all by itself. 2x, I'm getting rid of you by putting you on the left, so I'm going to subtract you. So now I have a negative 3y on the left. That equals, now this negative 2x is off to the right, so it's a negative 2x plus 9. Now let's get y all by itself, so we're going to divide by the negative 3. So y equals, a negative divided by negative is a positive 2/3 x. 9 divided by negative 3 is a minus 3. Here is the top one. Going on to this one, let's do the exact same thing. Let's get y all by itself. So 9x, we're going to subtract you to get you onto the right. So 6y is still on the left, and now we have a negative 9x plus 12 off to the right. Let's divide both sides by 6. And now we have y equals a negative 3 halves x plus 2. So all I'm looking at is the slopes. I'm looking at 2/3 and a negative 3 halves. They're clearly not the same. Are they negative reciprocals? One's positive, one's negative. One is 2/3, the other is 3 halves. Bam, we have ourselves negative reciprocal slopes. Reciprocal, you know what I mean. Reciprocal slopes. So if they're negative reciprocals, these two lines are perpendicular. You're going to get these problems in accelerated math, and I recommend you to solve them in this way. Put them both into y equals mx plus b form, and then compare their slopes. Let me know if you have any questions on this lesson when you come to class tomorrow. I hope this makes sense to you.